Dingle, I'm going to show you how I found the activation energy, what I think is the activation energy, I guess. So here's the data, and I plotted these first three because these are the low temperature ones I took at 15 degrees, 25 degrees, and 35 degrees. And I plotted it on this chart here. So first I looked at the dimer peak right here, and I just sort of estimated that it starts at 370 and ends around 400. So then I'm just going to integrate that, and by doing that I just take the first one and multiply it by the step, which is zero point 0.1 nanometers. Then I take the next cell and add the first one and multiply it by the next thing with the step, and then just drag it down from 370 down to 400, wherever that is. And then I can copy this over and do it for the other two. Damn it. There. Okay, then I look for the monomer peak, and I estimate that it starts about 110, and then I looked for the peak. I have to look for the peaks individually. I think that's what I started doing. And I said that this one starts, the peak is at 472. Oops. So I find it starts at 410, and I pretty much just do the same thing down here. Multiply it by the step, add the next one, and then drag it down to 472. There. Then the next one I estimate starts at, or the peak is at, about, I don't know, 470.5. So I just copy this right here, put it in the next one, and drag this down to 470.5, which is right there. And for the last one, I can estimate it starts in the peak. Damn it. The peak is 469, I guess. So just do the same thing. I don't know why it's acting up there. Take it down to 479. 469. Never mind. 469. That's it. That's right. There. And I don't know what that is doing. So I'm going to stop. Oh, I see what I did. I accidentally highlighted both of those when I dragged down. So I just want to drag this one down. That was 470.5. There. Okay, then I forgot for a moment what I did next. Alright, so if you look at the equation right here, I have to take the natural log of the dimer intensity divided by the monomer intensity and plot that versus 1 over temperature. So I go like right here, I guess, equals natural log of that divided by the lower intensity, the monomer intensity, the one that's down here, And this one, I integrated half of it, so I just want to multiply it by 2, and that should be the full thing. And then I have to do it for the other two. The last one, that should be good for those. Then I'll just put it in this column, the temperatures in Kelvin, 298 and 308. And then I should just be able to plot these. It's a scatter plot, make a trend line, see the equation. You could always do linist or something on this. And the slope is minus 1326.5. And if you look back at the equation, the slope should be the activation energy minus the activation energy over R. So if I just multiply that by 8.314, I get 11.02 kilojoules per mole. And that's it, maybe, I guess. I don't know.